Hey guys, we're back with the notes for 9.5. Today we're going to be solving using those rational equations and inequalities. We are mainly focusing on the equation part, not the inequality part, okay? All right, so let's go ahead and I suggest that you either use some colors or such so that you know what I'm looking at and why I'm multiplying by it. I think doing this in pencil would be very, very tricky if you don't have any colors to navigate, okay? All right, so here's our steps. We're going to restrict the domain on any problem to start us out. That helps us not only decide what we're getting and what we're not allowed to have, but it also helps us check for extraneous solutions. Because if you solve a problem and you get x equals 4, and you know x isn't allowed to be 4, because that's not in the domain, then it lets you know right away it's extraneous. Okay, so I want to do that step on all 6 problems first. So if you would, pause the screen, copy what you see. I have a little asterisk and an x does not equal next to every problem, okay? Perfect. So if I look at problem A, I say x cannot equal what? Are there any x's in the denominator that would make it equal 0? Yes, I have one right here. The x right here is not allowed to be a positive 4 because then my equation would say 2 over 0 equals something, and that wouldn't make sense. So right now, I know x can't be 4. If I go to B, I have x's in the denominator, but they're not binomials, they're just x's. So I know right now, x cannot equal 0. Let's go down to C. I have lots of x's in denominators. I can't have it be 0 because that would make both of those pieces 0. I also can't have these pieces be 0. That would mean -1 doesn't work either. So x can't be 0 or -1. Going into problem D, x cannot be positive 3 because that would make these two guys something over 0. Again, not allowed. If I went to E, we got a longer problem, but I can't let pink be 0. That would be using a positive 2. And I can't let blue be 0. That would be using a -2. So x can't be a positive or a -2. You will notice that I've already factored on problem E by breaking that difference of squares, x squared minus 4 into x minus 2 and x plus 2. All right, last one over here. X cannot be, I can't make the pink 0. Pink would be 0 if x was 2. And I also can't let blue be 0. Remember, we make that a fraction, so -2 over 3. Both of those are not allowed for my x answers. Okay? All right, let's go ahead and start looking at the next step. My next step is to eliminate fractions by multiplying each side by the least common denominator. Basically, I went through and I color-coded, and I'll kind of show you this right now. I color-coded all the pieces of the denominators that were the same. Okay? If there were 2 different kinds with x's in them, or 2 different kinds in general, then I went through and used different colors. Anything that does not have a denominator, you're going to assume it to be a 1. So like, for instance, right here, I assume this is 2 over 1. I assume this is 2 over 1. Okay? All right. Second of all, anything that is a polynomial on the bottom, you do need to simplify, or in other words, factor. So on E and F, I did have to break apart those 2 different polynomials, those trinomials and binomials. I broke them into their factors. We just got lucky that the pink showed up again and the blue showed up again, okay? All right, let's go back up to the top and let's start looking at what that looks like to eliminate. So if I need a least common denominator, I need to use the 5 and the x minus 4. Whichever piece is missing, remember we're gonna multiply that out. So the first piece is missing the 5. So I'm gonna go ahead and multiply him by 5 and multiply the top by 5. On the right side, he's missing the x minus 4. So I'm going to do x minus 4 and x minus 4. Okay, we're multiplying the top and the bottom. Once I get this done, I can strike through this whole denominator. I do not need it anymore. Okay, all I need to do now is simplify what I have. So on the left-hand side, I have 5 times 2 is 10. On the right-hand side, I do need to FOIL that together. So I have x squared minus 4x plus 5x minus 20. And since this is quadratic, I see that squared right there, I know that I'm going to want everything to get to one side wherever the x squared is positive. So he's positive right here. I'm going to move everything so it equals 0. I have x squared. I'm going to go ahead and combine these guys, so that's plus x. If I subtract that 10 over to the other side, I get minus 30. Okay? We're going to factor that because that's a pretty smooth factor. What multiplies to make negative 30, but adds up to make a 1? That should be a 6 and a 5. The 6 needs to be positive. The 5 needs to be negative. And that means when I solve this out, I get two different answers. My x could be a negative 6 or a positive 5. Neither one of those are extraneous, so we know that we're still good. Okay? I will go back and plug those in to check them once we get done with this step on every problem. Okay? So right now, I showed you the multiply to eliminate, the simplify, and the solve. Okay? We'll do the check again all at the same time. Let's go to B. All right, so B. I see that I have a denominator of x. Anybody who doesn't have that denominator, I need to put that. So we would do over x here and a multiply by x on the top. Now everybody has the same denominator, so I can strike through the fraction and I write what I have left. So I have a 5 plus the 2 and the x are going to multiply together and equal 6. This is a linear single variable. All right, so we're going to get all the x's on one side. We have that. We're going to move the 5 to the other side by subtracting it away. So 2x equals 1. Simplify it out, x equals 1/2. That is not my domain block. So we do still have to check that it's extraneous. We'll do that in just a minute. Okay. If you need to pause anything on A and B to write it down, go ahead and do that now. We're going on to C and D. All right, so for problem C, I have two different denominators. I have x's, and then I have x plus 1s. Any term that does not have an x, I'm going to have to multiply it. So this guy, I need to multiply him by an x, top and bottom. The last guy over here doesn't have an x plus 1, so I need to multiply him by that. Okay? Now that everybody has both pieces, I can strike through my fraction and write down what I have left. So 3 plus 3x, and then on this side, don't forget that this is a negative 1. So I've got to distribute the negative and the 1. So negative x minus 1, okay? All right, basic single variable, nothing quadratic, so we're going to get all the x's to one side. I'm going to move this x over here by adding it. That's 4x. I'm going to move this 3 to this side by subtracting it. That's a negative 4. Divide both sides by 4 gives me negative 1. Right away, I notice that that is not allowed to be my domain. So I say there are no solutions to this problem because this guy is extraneous. Okay? All right, so we're not going to go back and check that one at all. He just doesn't work. Okay? There are no solutions to this problem. Let's go ahead and look at D. D has only one variable required because this guy is technically over 1. So that means I need to create the x minus 3 under him and on top. So x minus 3 with that middle guy. Now that they all have the same denominator, I can strike through and get rid of the fraction, write out what I have left. So 3 equals, I'm distributing that 2. So 2x minus 6 and then plus 9. Single variable, no quadratics. So we're going to get all our letters to where they are. It looks like we've got 2x by itself. Let's just simplify real quick. So 2x plus 3. I'm going to move this 3 over here by subtracting it. Gives me 0. Divide by 2 gives me x equals 0. It does not match what's up here, so we're okay so far. But I will need to plug it back in to check and make sure nothing is extraneous. All right, if you missed anything on C or D, pause the screen, copy it down. We've got 2 more to go for simplifying and solving. All right, E is kind of long, so I want to go kind of slow. I did factor the difference of squares over here. He has the pink already, so the only guy missing pink right now is this guy, x minus 2 in the middle, so I need to multiply x minus 2 on top. Looking that he also has the blue, the only guy who doesn't have the blue is this guy. So x plus 2. I'm going to multiply it on top also, x plus 2. Now that everybody has the same denominator, I can get rid of the fractions. We're going to go kind of slow here because I want to make sure you keep all your pieces, okay? All right, This 5 is going to distribute with his new multiplier. So 5x plus 10. This middle is a negative 2. So I have to distribute him to both of them. So negative 2x plus 4. On the other side, the 8 already had everything he needs, so he's just an 8. Let's go ahead and combine. I'm going to put my x's together, 3x. Put my constants together, plus 14. We're going to move the 14 over by subtracting it. That gives us a negative 6. And we're going to divide it by 3, which gives us a negative 2. Looking up here, that matches one of my extraneous solutions. So on this problem right away, we're going to say no solution. And that is because x minus 2 is extraneous. Okay, so one more time. This one and this one, because it matched our domain block, we have no solution to this problem because the only solution we got is extraneous. Okay? All right, last one of these. In problem F, I did factor out my trinomial, and I got the two same factors that we've already used. So the only term that does not have the pink part is the middle, so x minus 2. I'm going to put that on top also, x minus 2. Only part that doesn't have the blue is this first guy, so I'm going to put 3x plus 2 here, and I'm also going to put it on this part, 3x plus 2. Notice I kind of organize my work to help me distribute or FOIL when I know I'm going to have to do that, okay? All right, everybody has pink and blue now, so we're going to get rid of the fraction. Simplifying on top. All right, I'm going to distribute this guy. That gives me a 6x squared plus 4x. Over on this one, and this is where it's a little bit tricky. I'm actually going to kind of do this in 2 steps. Let me show you real quick. This little negative guy, whoops. This little negative guy, I can actually change him from the beginning by saying if I distributed a negative, that would make the 4 negative and the 1 positive. And now I could treat this like adding, okay? So now, if I'm looking at these two, I can FOIL these two guys together to make another term. So let's do that now. So I'm going to have negative 4x squared positive 8x. Multiplying with the 1, now I have a 1x, and I have a minus 2. All of that is just the purple highlighted part, okay? All right, piece at the end, 17x plus 4. That didn't get any changes because he had the whole denominator already. Whew, all right, lots of simplifying to do. I definitely see I've got x squareds, and if I combine them, they would go positive on this side. So we're going to move everything to the left-hand side, okay? All right, over here, I've got 4x and 8x. That gives me 12. And if I move the 17 over, 12 minus 17 would give me a negative 5x. Ooh, I actually lost one. Sorry about that, guys. Let's go again. 4x, 8x is 12, 13x. Then minus 17 gives me a negative 4x. Sorry about that. All right, last part, if we take our constants and we're going to move that 4 over to this side, he would subtract, which gives us negative 6. Okay, and that goes with him. All right, quadratic. I do see a GCF right away, so I'm going to try and solve this with factoring. I'm going to pull out that 2. And I get lucky, this is going to factor. Numbers that would multiply to make a negative 3, that would also add up to a negative 2, would be a negative 3 and a plus 1. There's only 2 x's, so I only get 2 options. I have a negative 1 and a positive 3. So let's check with our options. Neither one of those are my blocks. So I don't know if they're extraneous yet, but they are not rejected, okay? All right, if you missed anything on E and F, go ahead and pause the screen, copy what you see. And we are going to go back one more time and check for extraneous solutions, okay? All right, so we don't have to check on C or E, but we do need to check on these ones, okay? So I'm going to go back and focus on the original equation, and I'm plugging them back in. Let me actually do this in orange, okay? All right, so my problem is 2 over x minus 4, so negative 6 minus 4, equals negative 6 plus 5 over 5. So I've got 2 over negative 10 equals negative 1 over 5. I would agree that those are equal. Let's do the same thing again, checking my 5. So I've got 2 over 5 minus 4 equals 5 plus 5 over 5. So 2 over 1 is the same as 10 over 5. I agree those are both answers, or those are both equal, sorry. So both of my answers work. Okay, let's do B. Plugging into the original equation, I'm checking 1/2. So 5 over 1/2 plus 2 equals 6 over 1/2. All right, 5 divided into halves actually gives me 10. 6 divided into halves actually gives me 12, and 10 plus 2 does make 12, so that one does work. If you missed anything on A or B, you could pause it, copy it now. Good, let's go to D. So D, I only have to check 0, so 3 over 0 minus 3 equals 2 plus 9 over 0 minus 3. All right, so we've got 3 over negative 3 is equal to 2 plus 9 over negative 3. 3 divided by negative 3 is a negative 1, is equal to 2 plus, and actually that would be a negative, 2 minus 3. I would agree, that works out. If you need to pause the screen, copy anything you missed for C and D, you can do that now. We have one last problem. All right, this one might go off the page. I'm actually going to kind of do it on the next page, but if you can fit it, that's awesome. Okay, so we are plugging in a negative 1 to that original problem. So I'm going 2 times the negative 1 over negative 1 minus 2 minus, I'm going the original problem, remember, 4 times negative 1 minus 1 over 3 times negative 1 plus 2. It's getting kind of long, stay with it. 17 times negative 1 plus 4 over 3 times negative 1 squared minus 4 times negative 1 minus 4. Okay. I'm going to stay slow and steady on this one, okay? All right. So on top, we've got negative 2 over negative 3. I'm going to go ahead right now and just get rid of those negatives. Minus, and then we've got negative 4 minus 1 is a negative 5. 3 times the negative 1 plus 2 is a negative 1. So I'm going to go ahead and get rid of these double negatives. That way it's whole. And then 5 over 1 is just 5. So I'm going to make this a whole number 5. Equals 17 times the negative 1 is negative 17 plus 4, negative 13. Negative 1 squared is 1, so 3 times 1 is 3. Plus 4 minus 4, those cancel off. So I'm going to just keep the 3. All right, so the question is 2 over 3 negative minus 5 going to make negative 13 over 3? Well, 5, think of how many thirds would that be? Be 15 thirds. So if this is already negative, make sure I'm not crazy on that. It was an, oops, nope, I lied. We already got rid of that negative, sorry. All right, so 2 thirds minus 15 thirds makes negative 13 thirds. Yes, I agree with that. I have the added benefit where I can copy this and paste it again. This time I'm going to change all those negative 1s to a positive 3. All right, so changing these guys to a positive 3. I'm going to change these guys to a positive 3. And then I'm going to change all these guys to a positive 3. All right, double check that's my equation. Yep. All right, let's run through this one. 2 times 3 is 6 over 1. 4 times 3, 12 minus 1 is 11. Over 9 plus 2 is 11. All right, let's simplify this real quick. I've got 6 minus 1, just so we're saying that's the same thing. All right, 17 times 3 is 51, plus 4 is 55. 3 squared is 9 times 3 again is 27. minus 12 minus 4. Okay, so I've got 15 minus 4 is 11. So 55 over 11 is the same as 5. So is 6 minus 1. All right, friends, if you missed any of that and need to copy it onto the other page, go ahead. But basically what we learned is that all of these solutions work. So general rule, you do have to show that you're checking. But unless your answer is blocked by the domain, you can almost assume that it's going to work, okay? All right. You guys have done great. I will see you next time.